there's going to be two ways that we can go about solving right triangles. And it's the stepwise that we've been doing, all of that stuff is the same. And that's what's really nice about trig. Once you get the basics down for trigonometry, everything else just flies. It's super easy. Excuse me. For example, today what I'm going to do a little bit differently is we'll start with the right triangle. See, this is 53. We'll call that 17. And I'm going to label it this way. And instead of it saying, hey, solve for x or solve for the missing angle, what we're going to do here is we're going to say, solve the right triangle. What that means is find all the missing parts. So you're going to have one of two ways of doing this. You're going to be, in this example, I gave you one angle and one side, which means how many other angles and how many other sides do you have to find? One angle and two sides, okay? And if I gave you two sides and no angles, you'd have one side and two angles to find. Well, either way that we go about doing it, they both kind of follow the same pattern. Now, what I want us to get accustomed to doing here first off is to first label what are the parts that you need to find. Well, here I have one angle and one side, which means I have to find one more angle and two sides. So what's the angle that we're missing? C. And then we're also missing the two side length AB and side length BC. We okay with that? Notice I did not put an X or a Y or a question mark or anything into the diagram. All I did was just label them as angle C, AB, and BC. Barrett, making this real simple. Now, what's really nice about this method, or for this style, is that since you're given one of the angles in the triangle itself. Hi, Mackie.
Hi, it's all your fault.
Thanks, Mackie.
You're welcome.
Since I'm given one of the angles in the right triangle, I can easily find missing angle C. Because angle A and angle C have to add up to equal how much? All three of them will be 180, but if I take out the right angle, those two have to be 90. Good. So what's 90 subtract 53? 37. Excellent. Everybody see how that's working? We know right away if I take 90 subtract the 53, that gives me 37 for there. And now you've heard me say this before. Now we're going to reuse the given information to solve for everything else. And that's the trick. You always want to reuse your givens. Here's what I mean. If I circle 53, the next thing I would do would be to draw to the opposite. Then I would label my hypotenuse, which by process of elimination gives me my adjacent. Excellent. According to this diagram, I have to find two parts. I have to find an opposite, and I have to find an adjacent.
Yeah.
I know my hypotenuse. So how do I find an opposite if I know my hypotenuse? Correct. What trig function do I use to find an opposite if I know my hypotenuse? Sine. What trig function do I use to find my adjacent if I know my hypotenuse? Cosine. So I'm using two separate trig functions. I know that the sine of 53 is going to equal my opposite, which is BC over 17. I know that the cosine of 53 is going to equal my adjacent over 17. And instead of using x's and y's and things, I'm actually just putting in what segment I'm looking for. That way I can go back and label it. It's the only difference in what we've been doing, guys. We're just doing two trig functions instead of one. Okay. So if the unknown is in the numerator, what do I do with the number in the denominator? You just multiply it across, and I do that for both of these values. So 17 sine 53 would equal segment BC, and 17 cosine of 53 would equal AB. Notice I'm writing down what my trig function stuff is before I press a button, because I'm going to ask you to do that always. And now I just press a button, and I round to the nearest 100. Okay. So if I do that, I type that in. 17 sine 53, 17 cosine 53. For the sine, I'm getting 1358. So for BC, I'm getting 1358, 13.58 for BC, and then 10.23 for AB. Yes, ma'am. Yes, ma'am.
Oh my god.
That's what it means by reducing given. That's exactly what it means. So what she was asking you guys is, you want to make sure that you use whatever numbers that you're given to start with to find what you're missing. Okay? Whether I'm missing a hypotenuse or I'm missing an adjacent, it's all dependent upon, remember this word, the perspective that you're given to start with. Okay? It's very straightforward. Let's try another one.
Okay, so 5D
Because I have an angle, I don't know the opposite, I have a hypotenuse. I have an angle, I don't know the adjacent, and I have a hypotenuse. I'm using the angle and the hypotenuse to find the opposite parts. Same thing goes for if you had it another way. Open the labels again. It works the exact same way if I have something similar to that. Once again, I drew a diagram real quick that had one angle and one side length, which means I need to find one more angle and two side lengths. So just like we did before, we always start by circling the angle, draw your opposite, label a hypotenuse, and label your adjacent. So in this example, I have to figure out what angle A is, what segment BC is, and what segment AC is. Of those three, what's the easiest? The angle, good. So if I take 90, subtract 14, what am I left with? Excellent. And now I go through the progressions of what do I do next to find sides. So you start again with the angle. I have an angle, I have an opposite. What trig function am I going to use to find a hypotenuse if I know my opposite? Sine, good. So I have the sine of 14 is my opposite over the hypotenuse, which is AC. And then what are you going to use to find the adjacent, knowing the opposite? Excellent. Use tangent that time. And now we're back to, in this case, both of the unknowns are in the denominator. What do we do with the trig function then? That's to find an angle.
Oh, no.
When we have the unknown in the denominator, remember we just do the good old-fashioned exchange-o, change-o. that's how we set these through. So let's see. Sorry. You guys agree with that? 140.54 and 136.37? Yes. One thing, I did this exact same problem second hour, and I realized when I typed in something, I did this. Why can't this equal, bless you, why can't BC equal 8.48? Is what? It has to be smaller than 34?
No.
Yeah. I don't know if you guys heard what Anna said. What Anna said was that it has to be larger than 34 because angle A is bigger than angle C. Since angle C is only 14 degrees, it means the other, since BC has got to be across from a larger angle, it has to be larger. So you'll remember those little tricks from time to time in case you happen to hit times instead of divide. And I caught that on myself or second hour today. I'm like, I made a dumb mistake. And we figured out why. So I just wanted to make sure I showed you how that worked.
Okay.
Well, it happens, but it's a learning experience. Now, what happens if you have something like this then? Sorry, I did the math wrong in my head. This is a little bit different. It is 26. What do you think it is? Yes, it's too wide. What's different about this one versus the other two we just did? Guess what? It's a joke. It doesn't have the A's. But guys, this is a 4. It was a joke. I'm sorry. I figured you guys can understand the sarcasm. That is a 4. I should have you come up here and you do the writing. Maddie, you come up next, all right? Now here's a trick here, guys. Everybody agree we have no angles, right? All right, so we have to find 2 angles and how many sides? 1. So we start by writing out. We need to find side or angle A. We have to find angle C. We have to find side AB. How do you find the side of a right triangle knowing 2 of the other sides? Yeah, you just use Pythagorean theorem. Okay. Whenever you have 2 sides to the right triangle, just use Pythagorean theorem. That's the easiest way to do it. So we know we have a squared, b squared, and c squared. Like we were saying, we're just taking c squared, subtract over, and you're doing it already. So we're missing a side length, which is AB. AB squared is going to equal 26 squared minus 24 squared. Yep, it's using Pythagorean theorem. So if you take 26 squared in the computer, calculator, whatever it's called, subtract 24 squared, you get dun dun dun. all I did here, rewrite this for a second. All I did here, that A was, we call that AB, because that's the side. I just wrote it down right away, knowing that I'd have to subtract that over. That's all that was. So that segment AB is going to equal 26 squared, subtract 24 squared. And what's the square root of 100? That's what we were doing. I just wanted to make a problem out real quick that I knew it was going to work. Now, going back, having to find two different angles, that means I'm going to have two different setups. Which one do you want to find first, A or C? Or does it even matter? Doesn't matter. Well, I might as well start with A. If I start with A, what's the 24 to the relation of A? Opposite. Very good. So that becomes an opposite. 26 is its hypotenuse. Do I need to bother labeling the adjacent? No. Since it's not known information, it wasn't given to me, I'm not going to use it. Even though we just solved for it, what happens if we solve for it incorrectly? If I use an incorrect piece of information, will I ever get a correct answer? No. That's why we always go back to reuse givens. So we use sine. So I know that the sine of angle A would equal 24 over 26. Just like before, how do you get the A by itself? The inverse, very good. We use the inverse of the trig function. So I know that angle A equal the inverse sine of 24 over 26. And then we go back to pressing buttons. I'm getting 67.38.
Yeah.
Okay. And now we go to angle C. Angle C, if I start here, there's the opposite now. What does the 24 become in relation to angle C? It becomes the adjacent. So now it's no longer an opposite, it's now an adjacent. What trig function do I use to find angle C? Cosine. Okay. I'm using two different trig functions because I have two different angles. So the cosine of angle C is 24 over 26. The adjacent is the 24. If I'm at C. Whenever you're using sine or cosine, the hypotenuse will always be bigger than 2 bars. And in this one, I'm getting 2262.
Yeah.
You okay with that? Means I just go back up and I write down what we had. Thank you. Hey, what do you think 6738 and 2262 should add up to equal? And if they don't, then you've probably done goofed somewhere. Is this all? Yes. This is all there is. Yes, ma'am.
Okay, so you're 1 point.
From what?
You're 1 point away.
Oh, but he's signed up for it now, not me. Nope. He won. He beat all the math teachers by 0.1%. So he's in the final running right now, not me.
Have you ever had somebody put $40 in their bucket?
Somebody that wanted to donate the money to charity.
Well, you could do 20 in favor and 20 in another one.
Yeah.
Still $40 to charity.
Or, I know, but like, you didn't have to pick up.
No, I'm just laughing.
This is all of, so we're gonna put in the so here's so. Michelle's not here.
All right,
I used to work in the office.
take a minute. Write down what parts you have to find, and then find them. Remember, show your work, show what you're about to type in the calculator prior to typing. Nope, busy. So we have what? AC, angle A, and angle C. I'm the worst. 15 squared plus 12 squared. I don't know. What? Oh, Maddie! Finish this one. I'm bored. I need to drink some more coffee. Oh, you don't wear glasses? Can you see what you're doing? It's a bad high five. Come on now. You did a high five! This is much more.
So the first thing that we do, we need to find the hypotenuse. So we have to do the Pythagorean theorem.
I can't hear learning.
So you do the a squared plus b squared c squared. So we need to find AC. So AC squared equals 12 squared plus 15 squared. And that will give you some big number, and then you have to do the square root thing. So that equals, so then AC equals
Can you read?
3. So we found the hypotenuse. And then you need to find A and C, which you can just start wherever. So I'm just going to do A, which means this is the opposite. This is the hypotenuse, but we won't need to use that since we just found it. And then this is the adjacent. So, since it doesn't have the hypotenuse, we're using tangent. Over 15. And then since you're trying to find angle A, you do the reverse thing. Inverse thing. I'm using a slash. I heard you hated that, so still doing that.
Why are you using slashy fractions?
Because that's how I write it. I like it to be on one line. Because if you write it with a number on top, it always goes into the next line.
Boy, paper is so expensive.
So that makes angle A 38.66. And then you do the same thing for angle C, which you still use tangent because we still don't have the hypotenuse. Can I make a new page?
Or just scroll down.
Okay, so now we're finding, oh no. So now we just have to flip them since we're still using the same thing.
Guys, hold on.
Okay, so we basically have to do the same thing. We just have to do the inverse And that will give you 51 points.
Ladies and gentlemen, Miss Trig herself. The Trig, they're the most exciting thing in the world. Okay, on these things here, I didn't expect. Oh, no. I was anticipating having to do more examples and more problems with you guys, but the sounds of what things are going, it's flying through real quick here. Do just the evens on this one. Okay, just the evens. Now, one thing I want you to notice, as you're scrolling through this, you'll notice the evens are basically in the second column. Now, if you flip over to the second page, you'll see that after number 8 and number 10, there is not a list of what you have to find, which means you have to start writing out your own lists. What I did on this sheet here is what I started to make ones that you had the lists, and then I took away some of the lists to make you have to find them yourself. Same thing with the last couple pages going into like 14, 16, 18, and 20. So there's like, 5 you have the lists and 5 you have to make up on your own. All right? Round to 2 decimal places like we have been. If your calculator spits out a root, that's fine. It's not a big deal. One thing that will happen, if you look at number 6, what kind of a triangle is number 6?
Right.
Yes, it's a right triangle. It's a 45, 45, 90. Do you have to use the special right triangles to solve for the sides and stuff? No, if you use trig, it'll still work. So when you use trig with sines and cosines and tangents on your calculator, you're still going to get root 2s and things. It's fine. It'll happen. You don't have to if you don't want to. All right. We'll go from there. Tomorrow we'll do elevation, depression, and then we'll cross our fingers for what we're doing on Monday.